Hi everyone, this is Sai. I would like to explain my video on inflammation. And here we go. Inflammation and immune response. Inflammation is derived from a Latin word called inflammatio, which means to set on fire. The main motto of inflammation is to bring the defense cells or the immune cells to the site of damage or cut to destroy the invading pathogen and start the repair mechanism for the damaged cells. Speaking about the types, there are two types of inflammation: acute inflammation and chronic inflammation. Acute inflammation is an immediate response from your body, and chronic inflammation is a very slow response, which results in the permanent tissue damage. Inflammation always carries a suffix called itis. For example, dermatitis is an inflammation of skin. So, this is a small introduction about the inflammation process. When looking into the inflammation process, we should understand one single step that inflammation is not a step by step process that is happening. Multiple reactions will happen at a single point of time. So, I would like to explain these reactions as steps, right from the basic skeleton, pathogen entry, followed by the immune responses of the body. But it may need not be a sequential order that is going to happen in reality. Looking into the sequential layers, first comes the tissue layer of the skin. Beneath the tissue layer is the mucosal layer, and next is the blood vessel. This is a single blood vessel, and the blood capillary is being denoted in blue color. There is a lymph vessel that is found in the cell layer, which in turn is connected to the lymph node. When looking into the blood vessels, we have many types of cells and plasma proteins, like erythrocytes, which is nothing but the red blood cells, and monocytes, which is indicated in the purple color, and neutrophils, which is nothing but the phagocytic cells that is found in the blood vessel. We also have other type of proteins like inflammatory mediators. There are two types of inflammatory mediators: plasma derived inflammatory mediator and cell derived inflammatory mediator. As the name indicates, plasma derived is found in the blood vessel and cell derived is found in the cell. Plasma derived is of two types: complementary proteins and kinins. They play an important role in the inflammation reaction. When looking into the tissue layer of the skin, it contains macrophages and as well as the mast cells. The mast cells contain histamine granules, which is also a cell derived mediator. So we have more number of macrophages and mast cells that is found in the tissue layer of the skin. So when the cut or the abrasion happens, the blood will flow out, which paves a way for the pathogen to make its entry into the skin. During injury, the pathogen enters the body and triggers the inflammation reaction. So it contains certain protein molecules on its surface, which is called as PAMP, pathogen associated molecular pattern. These PAMP molecular patterns are being recognized by the macrophages and the mast cells, that is nothing but the immune cells. And once the mast cell recognizes the PAMP of the pathogen, it releases the histamine that is stored in its granules. So this histamine is a cell-derived mediator. They can cause two types of effect in the system. One is vasodilation and other one is vascular permeability. Vasodilation is nothing but the dilation of the blood vessel, and increasing the vascular permeability will lead to more gaps being formed in the blood vessels so that the blood will flow out and the immune cells will enter into the tissues. So the neutrophils enter into the tissue layer, and the monocytes, once it enters the tissue layer, it is called as macrophages. The process of immigration of these blood vessels into the tissue is called as diaperesis. So when these macrophages recognize the PAMP of the pathogen, it secretes cytokines, which is also an inflammatory mediator. Particularly, it has TNF alpha and interleukin 1. It can cause two types of effect, local effect and systemic effect. Local effect is nothing but the inflammatory reaction, that is vasodilation and increased vascular permeability. And systemic effect is fever and leukocytosis. When speaking about the lymph node, if no infiltration occurs in the lymph node, it contains naive B cells and naive T cells. We also contain Langerhans cells or the dendritic cells on the tissue layer of on the surface, which acts as an APC, that is antigen presenting cells. Next comes the tissue repair. First and foremost, the tissue repair is being initiated by cytokinins, which stimulates the fibroblast activity. These fibroblasts proliferate and increase the collagen synthesis and helps in the tissue repair mechanism. Next comes the blood vessel repair, which is being performed by the coagulation cascade, which also helps in the tissue repair mechanism. Chemotaxis also aids in tissue repair. So going back to the inflammatory mediators, we have already seen the plasma derived, that is the complementary proteins and kinins. When these complementary proteins on addition with an antibody, it can cause two types of reaction. One is opsonization and other one is lysis. When speaking about the opsonization process, the bacteria is being coated and it aids its detection to the macrophages, which is nothing but the antigen presenting cells, for the destruction of the pathogen. Lysis is a reaction whereby a hole is being created on the bacteria and cause the bacterial cell to burst. The common proteins like C3A and C5A are very important inflammatory mediators, which also helps in the tissue repair mechanism. Speaking about the cell-derived mediators, we have already seen two types, cytokines and histamines. We also have arachidonic acid metabolites, which is also a cell-derived mediator. Mast cell or any other type of cells, particularly granulocytes, will secrete prostaglandin and leukotrienes, which is also an arachidonic acid metabolite, and it can induce fever and pain. Once the immune cell reaches the tissue layer through diaperesis, they express certain special receptors for PAMP, and they engulf the pathogen through a process of phagocytosis. For example, what will happen without these inflammatory mediators in the innate immune system? If a pathogen is going to attack the system, the adaptive immunity has to be initiated. These cells are within the lymph nodes. So the antigen presenting cells enters the lymph node through a lymph vessel, so adaptive immunity is being activated, whereas the B cells and the T cells are activated. B cells are converted to plasma cell and plasma cell is converted to antibody. Whereas speaking about the T cells, after activation it is being converted to either a T helper cell or a T killer cell. These are nothing but the lymphocytes. So overall, the antibody is being generated by the plasma cells. Like there are various type of antibodies like IgG, IgM, and IgD, and these antibodies stimulates the inflammatory response to remove the pathogen from the body and bring back the system to the normal. So there are n number of antibodies that are being produced. Speaking about the lymphocytes, they are very specific in attacking the pathogen and they play a crucial part in the adaptive immune system. Finally, the blood clot is covered by the tissue layer, and as a result of the tissue repair mechanism, that's the end of the immune response, and the system is brought back to normal. In inflammation, we have to remember certain Greek words like scalar heat, which is happening due to dilation of blood vessel, and tumor is nothing but the swelling which happens due to the leakage of the plasma fluid from the blood vessel and tissue. Dolor is a pain created which is due to the sensory nerve fibers firing and mechanical damage. And loss of function happens only in chronic inflammatory reactions. And This is an overall view of the inflammatory process that is happening in our body. And that's it. Thank you.